Hello and welcome on to GambitoR IIT Roorkee YouTube channel. Today we'll be starting a solution series for Metiox Inception round sample papers, and we are here with question number 1, 2 and 3, which were paragraph type questions, and the paragraph gave information about 5 people. It is Sherlock, Lestrade, Anderson, Donovan, Watson, and the paragraph gave information about heights of these 5 people. So what the paragraph says is these 5 people were numbered according to the heights, with the tallest person was given position number 1, second tallest was given position number 2, and so on till position number 5. And SO is a sixth person which was mentioned in a question, and by default we'll assume position of SO to be 6. And here the first letter of the name of these 5 people is used as their position. So S denotes position of Sherlock, L denotes position of Lestrade, A Anderson, D Donovan, W Watson. And these positions S, L, D, A, W vary from 1 to 5. And there are 3 statements given in the question, and we can use these statements to reduce 3 simple equations. That is S plus D equals A plus L is less than 5, S is greater than 1, L greater than S, A greater than W. Now we can use these 3 equations to reduce the question to a table with which we can solve the question easily. Okay, so here is the table that we'll be using to solve the question. Now, how can we reduce the question to this table? We'll be using the equation L plus A is equal to D plus S, and what we'll be doing is we'll be assuming 2 cases. Now L minus S can take only 2 values, 2 and 1. That's because L is greater than 5 and S is greater than 1. Sorry, L is less than 5. I'm sorry, L is less than 5, S is greater than 1. Now this ensures that L minus S cannot be 4 or cannot be 3, because for L minus S to be 4 or 3, either one of L or S or both of L or S has to be either 5 or 1, and this is not possible. So L minus S cannot be 4 or 3. So for L minus S to be 2, the case is L being 4 and S being 2. For L minus S to be 1, there are 2 cases, L being 4, S being 3, L being 3, S being 2. Now let's look at the 3 cases. So the 3 cases. Now L being 4 and S being 2. So to be D minus A, for D minus A to be 2, there is only one possible case, it's 5 and 3. The other case is 3 and 1, but that's not possible because W will be 5 and that's not possible because A is greater than W. So 5, 3, 1. That's the only possible case. Okay. So for L being 4 and S being 3, D has to be 2 and A has to be 1 for D minus A to be 1, and subsequently W becomes 5, but that's not possible as A is greater than W. So this is not possible. Okay, so for 3 and 2, L becomes 3, S becomes 2, D becomes 5 and A becomes 4 to maintain the difference to be 1, and subsequently W becomes 1. Now this is possible and it satisfies. So there are 2 feasible options, and the options are W, S, A, L, D, E. E is your SO, whose default position we assume to be 6. The second option is W, S, L, A, D, E. Now we'll look at the 3 questions, and question number 1 is who is the tallest. That is obviously Watson. In both the cases it's Watson. That's Watson question. Option number A. Question 2. If Anderson is shorter than Lestrade, Anderson shorter than Lestrade. So this is the option that we are looking at. Sum of position numbers of which of the following combinations is a perfect square. That is Watson plus Lestrade becomes 4 and Anderson and Donovan becomes 9. And Anderson and Donovan is an option. Watson and Lestrade is not an option. And Lestrade and SO also becomes a perfect square, but SO is not mentioned in an option. So the correct answer is B. Again, if you look at question number 3, none of the options is correct. Option number E. So we are over the solution of question number 1, 2 and 3, and we'll come back with further solutions. Thank you.